I don't know how to explain the vision that I have because I don't know what the vision a normal sighted person has looks like. I can see what's a little bit ahead of me, and I can see the people around me and hope that they help me see what I can't see. My name is Brennan Cavanolo. I'm 17 years old, and I have X-linked juvenile retinoschisis.
Over 10 million people in this country are dealing with these vision-robbing diseases every day, including my son and people I know and love. And it's time for that to end.
Can you draw a B on it?
I think all parents want everything for their children. If my son had any disability, I would be incredibly hopeful that a scientist somewhere out there was working very hard to help my child. I'm Shannon Boye. I'm a PhD researcher here in the Department of Ophthalmology at the University of Florida, and I spend my days developing gene therapies for inherited retinal disease.
I have a lot of hope that gene therapy will be able to cure every retinal condition that the Foundation Fighting Blindness works towards curing.
How are you? Good to see you. The question of can we treat blindness today? The answer is yes. But our current methods only work for certain conditions. So what that means is that what works for one form of LCA, for instance, won't work for Stargardt's disease. So we have many, many more gene therapies to develop so that we can treat patients that have all of those other inherited retinal diseases. That looks really, really good.
Yeah.
Lots of bipolar cells.
I was excited about this.
The question that we're asking as gene therapists is quite simple, and that's, can we take a healthy copy of the gene, deliver it to the person or the individual's photoreceptors in their retina, and have that healthy gene go on to make a normal protein that can then perform the function that it's supposed to perform? So the best way we've found is to use a virus. When you think about when you get a viral infection, the virus, creeps up into your nose, it infects your cells, and then it releases its DNA. So that's what viruses do naturally. So what we're doing is we're harnessing nature by taking a healthy copy of a gene and putting it inside a virus. First, of course, we remove the virus's native DNA, so it's not going to infect you and actually make you sick. I think of the virus as a taxi cab, and the healthy gene as the passenger inside. As a gene therapist, my job is to tell that taxi cab where to go and drop off the passenger. Right now, the state of the art in terms of how a patient receives a gene therapy requires complicated surgery where the retina is temporarily detached. This can be a risky procedure. My lab is working on AAV viruses or taxi cabs that are sort of newer and stronger that can be placed in the front of the eye in the vitreous and then penetrate all the way through the retina and infect the same types of cells. If we can generate vectors that can be placed in the front of the eye, then those patients can walk into any clinic and have their injection performed on an outpatient basis, walk in and walk out. So where we're at now is we've developed these taxi cabs, and we've shown that they have the ability to get to the photoreceptors after they're injected in the front of the eye. But what we need to do is get more taxi cabs into more photoreceptor cells. So that's the problem we're working to overcome right now.
My family, literally, we felt like we were alone battling this disease. Just telling my son to suck it up. This is the disease you have. You're going to have to learn to live with it, do the best you can in life, and overcome the obstacles. And that's still the message while we have the disease. But now there's also hope that we're going to cure the disease. Thank you. And again, thank you all for everything you do. It really means a lot to us. We want Brendan to be able to drive one day. And thanks to people like you, we think he will.
Thank you.
I like to have patients like Lisa and Brendan come into the lab on a routine basis because it reminds you that what you're working on is potentially going to be injected into someone's child's eye. The Foundation Fighting Blindness gave me my first grant. They took a gamble on me, and because of the data that I was able to generate with their funding, I was able to compete successfully for a larger federal grant, and the rest is history. The Foundation Fighting Blindness is doing this for a lot of young scientists, as well as, many established scientists that are doing wonderful things. So they've been absolutely pivotal.
Now it's more important than ever to donate to the Foundation Fighting Blindness because so many clinical trials are either starting or about to start. There's so much research out there that's actually meaningful.
I'm excited to be working in the field at such an important time. We're restoring vision to these patients, so it's an incredible time.
There needs to be a lot more people donating to the Foundation for Blind and Blindness, because without their donations, the Foundation for Blind and Blindness does not have the money to give to the research.
You've got to donate now.